we start off the session with Sang-Song Kim from Korea Advanced Institute of Science and Technology. And as I understand, it will be a video. And thanks Tech Support for starting with our first presenter on neural correlates of creative drawing, a study of the relationship between EEG and the domain-specific creativity scale.
Hi, I'm honored to be able to share our research on the neural correlates of creative drawing and following insights on mindfulness. My name is Sang-Song Kim and I am an undergraduate student at KAIST School of Transdisciplinary Studies. Also, I have been studying contemplative science at KAIST CCS for 2 years, which I'll introduce soon. And I could conduct this research and do this work with help from my colleagues, including Son Hwa-hang, a physics major undergraduate, and Professor Eun-mi Kim. First, let me introduce our research center, KAIST CCS, and why we chose to do this research. KAIST stands for Korea Advanced Institute of Science and Technology, and it's probably the best STEM-focused college in South Korea. CCS stands for Center for Contemplative Science, and we are the only scientific contemplative research institute in South Korea. Our first goal is to scientifically evaluate the mechanism of meditation. We may compare different meditation methods. Based on that, we can better understand their benefits and suitability to different groups. Actually, that's what most people in this field do, understanding the mechanism and effect of meditation, developing tailor-made or technology-assisted programs. Although being a research center, our second goal is offering mindfulness-based courses for all campus members, from students, professors, to workers. This is also related with our research, as those participants are sometimes used as subjects for our research. Our center has been offering MBSR, which stands for Mindfulness-Based Stress Reduction, since 2020 for international students. Its goal is to reduce stress and cultivate a mindful and self-compassionate attitude towards oneself and others, but Professor thinks those attitudes may affect creativeness. The course contained some creative activities such as drawing or moving, and the participants were instructed to do them mindfully. We wanted to see how the participants' creativity changed after completing the program, but due to Corona, we couldn't recruit enough participants. Actually, most of them were participating in the class outside of South Korea. Instead, together with the control group, we did some research with a different approach. Anyway, we hope we can one day propose a better way of cultivating creativity or environment that facilitates creativity, probably applying some mindfulness. Before introducing our study design, I need to say something about creativity. Nowadays, creativity and innovation are much valued, and the role of education to cultivate students' creativity is being emphasized more than ever. However, our knowledge about creativity is very limited compared to its importance. Creativity is discussed in various contexts such as ability, tendency, attitude, and there will be different definitions of them accordingly. There are also various approaches to the ability creativity. Some view creativity as a cognitive process or construct and focus on the psychological or neurophysiological correlates of each of the components of creativity. And it's also controversial how we should divide the components that construct creativity. Others study how creativity interacts with various features of education, such as motivation, and others study how social interactions or environments like evaluation, reward, task constraints affect creativity. Since all of our lab members have a STEM-focused background, we chose to take a neurophysiological approach in this creativity research. We also wanted to add some work in the attempt of developing a quantitative and objective measure of creativity. Neuroscientific creativity research has these three main topics. Firstly, divergent thinking is a spontaneous, free-flowing thought process or method used to generate creative ideas, exploring many possible solutions. It is usually followed by convergent thinking, where ideas and information are logically organized and structured in a goal-oriented manner. Secondly, as many would relate creativity with artists, there has been many studies comparing successful artists with normal people. Lastly, some observe what happens in one's brain at the moment of inspiration, also called the eureka experience. The picture you're seeing is an image drawn by one of the participants of the MBSR course. Actually, he is also one of the subjects of our research. Can we tell whether this picture is creative or not? Well, it's a hard question, and what makes it challenging is that creativity is dealt in so many contexts, and there's no consensus in its definition, and it's hard to measure. Um, there are some stereotypes about STEM-focused students in Korea, that they are robotic, they lack emotion or artistic creativity. But at the same time, they are considered nerdy and full of innovative ideas. Even the new president of KAIST, who was famous for always reading books or papers upside down to keep a fresh point of view, emphasized creativity of the students. So these questions came up to our mind. Do we actually need more creativity? Wouldn't it be more than enough eventually driving us crazy? And if so, assuming that creativity is a multi-dimensional trait, which creativity would we like to have more? And how can we have it more? It seems we need a better theory explaining creativity with an objective measure. There has been two approaches in measuring creativity, self-report and creative tasks. The former asks how creative he perceives himself in various circumstances that fall into one of several domains. The latter asks the subject to fill out a picture from partial curve or empty circle, or complete a sentence from only a few words in a limited time. Then those answers would be evaluated as creative or not, and the number of creative answers indicate one's creativeness. These methods do produce some sort of numerical scale, but are suspicious. Do they properly represent general creativity? And they also seem quite subjective. In this situation, neurophysiological measures are quite appealing as they seem objective while being quantitative also. But while conducting the experiment, we realized that creativity cannot be reduced to a simple brain activation feature, like most other cognitive processes. So this is the objective of our study. Uh, it is to find the correlation between KDOX, which is one of the self-report creativity scales, and some features of EEG signals during creative drawing task. Also, because all of our subjects are from STEM-focused college, it would be interesting to compare their KDOX scores to other groups in different studies. So this is the group features of our participants. There were 22 male international undergraduate STEM students at KAIST. They were all male, it sometimes happens in STEM-focused colleges. And they were actually combination of two groups. 5 of them attended the MBSR course, and the rest 17 were controls. But all the data that we have used for this study were measured before the start of the course, so they can be considered quite equivalent. And their age was minimum 21.1, and the standard deviation was 1.7 years. Also, we made sure that none of them had prior experience with breathing meditation. Now I'll explain KDOX, which is the measure we are going to use. KDOX measures creativity of the participants using 94 developed and validated items. All of the items fall into one of the 5 domains: mechanical science, self-everyday, scholarly, performance, and arts. So self-domain explains how intrapersonal and interpersonal creative behaviors in every life. Scholarly domain reflects engaging in deep analysis and pursuits that involve gaining knowledge. And performance domain deals creativity in activities such as music, writing, and acting. And science and artistic are as it seems. So for every items, the subject assesses how he perceives himself to be creative in activities that fall in one of the domains, from very low to very high. This is the example of TTCT test. We made the subject to fill out this test while being measured by EEG. It was developed by Torrance, and it evaluates the divergent thinking ability of the subject. In our experiment, we used only picture completion tests, but there are other problem sets, including adding lines to a pair of parallel straight lines, or filling out blank circles. We can evaluate the degree of creativity by counting how many successful creative answers he produced in a limited time, but we didn't do that because we only used partial questions. So here's the method. With respect to 22 participants we have recruited, we made them complete the KDOX questionnaire before participating in the experiment, and then they performed 7 tasks, including TTCT. The exact protocol will be explained soon. And during those 7 tasks, EEG signals were recorded. So these are the 7 tasks. For baseline measurement, the subjects had their eyes opened and closed for 3 minutes each, and then they were asked to do the picture completion task for 3 times, and each of the tasks were 2 minutes long. And between the 3 tasks, the participants were instructed to do random thinking or breathing meditation. This is the descriptive statistics of the KDOX survey. Score 1 means the person evaluated himself as very uncreative, and score 5 means the participant evaluated himself to be very creative. As you can see, performance and artistic domain was scored very low, and it's understandable as all of the participants were STEM-focused students. We did correlation analysis between relative alpha power, relative slow alpha power, and relative fast alpha power in every 8 channels, as you can see in the left, FP1, FP2, T3, T4, O1, O2, FZ, and PZ, with 5 KDOX values in each of the 5 domains. So the KDOX values would lie somewhere between 1 and 5, and relative alpha power should lie somewhere between 0 and 1. And these are the only pairs of EEG parameters and KDOX values that had significant correlation. As you can see, there are significant negative correlation between performance domain score and alpha band power, also slow alpha band power, in T4, PZ, and O2 channels. So it seems that alpha synchronization in brain in parietal sites means some efficient memory processing and memory search and retrieval. Also, alpha synchronization in posterior parietal and occipital sites indicates a suppressing of incoming visual informations. Actually, for every subject, we had done some interviews after the experiment. And as a part of the interview, I asked them what tactic they applied for doing the task. And I remember some of them replied trying to recall their memories of a scene of a fairy tale or some landscape of their hometown, while others reported that they somehow filled out only a small portion of the picture, and then they waited for some other ideas to pop out. And then with the idea, they expanded the picture once more, and then they waited for another idea. So they gradually expanded the picture, but they had no clear direction. So I thought that those two different tactics can be related to high alpha synchronization or low alpha synchronization. So high alpha synchronization in those three channels indicate the participant tried to recall memories when filling up the test picture. So they were dedicating their cognitive resource and memory approach and suppressing their cognitive resource in processing visual informations. Uh, in contrary, low alpha synchronization indicates the participants were improvising. They expanded their drawing step by step by using random inspirations, and some of them could have originated from visual, somewhat distracting informations. And also because such high alpha synchronization was related with low score in performance domain, it seems that people with higher performance domain score tend to stick with the improvisation approach. Well, it sounds reasonable because the performance domain indicates how somebody is creative when doing like activities such as writing, drawing, or acting. So as a conclusion, I first want to point out how the participants in this group rated themselves low in their creativity for all domains. Well, they rated themselves very low in performance and artistic domains, but they are they are very great students in STEM fields, but they also rated themselves quite average score in mechanical, even in mechanical and science domain. And we think this kind of low self-rating originated from a self-critical and self-limiting attitude towards their own creativity formed in a highly competitive environment. And I think they need for some compassion and mindfulness training will help. Also, mindfulness training will not only help them with their self-evaluation on themselves, but through that, it can also cultivate their creativity because those self-critical and self-limiting attitude will hinder them doing challenges. And also, the participants showed two different tactics when being given the same task, improvising or memory retrieval. But we cannot say that one is more creative or more desirable than another. It's always better to have more options in your hand and being flexible in choosing them depending on the circumstances. For that, we need to be aware of oneself and others, and be mindful in daily lives and share insights with others. So by that, we'll be able to incorporate more approaches and wisely decide which one to use in every problems. So I would like to say that being mindful can help us be more creative. Um, Unfortunately, there are limitations of our study. First, we failed to interpret significant correlations between other wavebands such as beta or gamma and other KDOX domains. Also, there are other ways to interpret alpha synchronization in those regions, and one of them is relating them with different procedures during creative or divergent drawing tasks. Some papers say that divergent thinking composes of idea generation, elaboration, and evaluation steps, and each of them would produce different patterns of EEG signals. So in future research, we might want to divide the creative task into different steps that involve a more homogeneous cognitive process. But anyway, this was our first research, and what's important is whether we will mindfully continue our research. I also would like to thank my colleagues, including Sunhwa Hwang and Professor Gina, for their physical and mental support and their participation in the research and writing papers. And thank you all for listening.
We heard a very fascinating approach towards discovering the mystery of creativity from the Korea Advanced Institute of Science and Technology. As it was a video presentation, we cannot ask questions, unfortunately.